Hi ladies, this lesson is on area of a sector and there's a new formula to remember and it's A equals half r squared theta. So where does the formula come from? Well, if we say that the ratio of the area of the sector, this writing's very bad, to the area of the whole circle is equal to the ratio of the angle theta to the angle in the whole circle, that whole revolution there, then we can substitute in what we know to get this formula. So if we say A is the area of the sector, and the area of a circle, you know, is pi r squared, we'll say that equals theta, and a whole revolution we're going to say is 2 pi radians. So that means then our theta is going to be in radians. Okay, so both our areas are in, say, centimetres squared, and both of our angles here are in radians. So then if we multiply both sides by pi r squared, the pi's will cancel, and we're left with pi r squared on 2, or another way of writing that is half r squared theta, where theta is in radians. Okay, now in Year 10 you may remember learning another formula for the area of a sector, and that was when theta was in degrees. And you know the area of the full circle is pi r squared, so the area of a sector would be theta on 360 times pi r squared. So you could use either of these formulas depending on if your angle theta is in radians. If your angle theta is in radians, then you'll use A equals half r squared theta. And if you've got theta in degrees, then you could use A equals theta on 360 times pi r squared. Okay. So using A, equals half r squared theta. And we're just substituting in. So you've got the radius is 2 squared and theta in radians is pi on 6. Okay, because the question says find the exact area, that means you want to leave your answer in terms of pi. So your answer is going to be pi on 3. Because the radius is in centimetres, that means the area is going to be centimetres squared. Next example, find the area of a sector corrected 2 decimal places if the radius is 3 centimetres and the angle subtended is 60 degrees. So because our angle is in degrees, we can either use the formula A equals theta on 360 times pi r squared, or we could convert this angle in degrees to radians. So 60 degrees is pi on 3 radians, and then we could use the new formula that you've just learnt today. So if we're using the junior school method of theta on 360 times pi r squared, it'd be 60 on 360 times pi times the radius, which is 3 squared. And you should get 4.71 centimetres squared. If you're using the formula that you've just learnt today, A equals half r squared theta, where theta is in radians, then it's going to be half times 3 squared times pi on 3 radians, because 60 degrees is pi on 3 radians, and you should still get the same answer, 4.71 centimetres squared. Okay, into a multi-step problem now. This question is has given you the area of this sector is 56 centimetres squared, given you the radius is 8, and the first part is to find the length of this minor arc AB. So what they're asking you to find is that length there. Now you may remember from the last lesson, to find the length of an arc, it's L equals r theta, where theta is in radians. Now we have the radius of this sector, but we don't have theta. So we need to use this information here and the area of a sector formula to find what theta is first, and then we can use the arc length formula. So using A equals half r squared theta. The area is 56. And the radius is 8. And then solving that equation to find theta, and you get theta is 1.75. And remember this formula, theta is in radians. Okay, so then we can use our arc length formula. So L equals the radius, which is 8, times theta, and with the arc length formula as well, that theta was in radians. So our arc length then becomes 8 times 1.75, which is 14. And because the radius is in centimetres, the arc length will also be in centimetres. Alright, then part B is saying the straight edge OA and OB are joined to form a right circular cone. So similar to the example we had in the last lesson. So they're curling around to make this cone here. And then that will be the new radius. Then find the base radius of the cone in irrational form. So remember this arc length here, if we're curling around OA and OB, that arc length there will then become the circumference of the base of this cone. Now the circumference of a circle is 2 pi r, and that's going to equal this arc length, which we already found, which was 14 centimetres. So rearranging that to make r the subject, you can see that r is going to equal 14 on 2 pi, or simplifying that will make 7 on pi, and we do want to leave it in that form because the question says to find the radius in irrational form. And because the arc length there was in centimetres, the radius is going to be in centimetres.